Welcome back to Transcended Institute and the Stud Hub, the only stud hub that went to the private school. So, in today's video, we are going to talk about Newton's laws of motion. I have practically a lot of questions that we're going to talk about, and I want you guys to follow through one by one. If you have got some ideas, pause the video and try to solve it, then compare with the answer that I'm going to find. But before I get into it, I want you guys to know that I have solved quite a number of questions for past papers for 2023 and 2024. So this is the paper for 2024, and I want you guys to know that I have solved almost all the questions in this paper. Now you can access the video, the full video for this paper from the website. The video is ready on website. That's the same as even the one for 2023. The video is ready on website. So don't waste time, revise with Transcended. That's the only way which can help you to catch up. So without wasting much of your time, let's get into it. Let's talk about Pulley system. So what's basically Pulley system? So Pulley system is a simple machine that happens when you have got two objects, then you are trying to pull another one under the influence of gravity using the other object. For example, the diagram that I have here, my goal is also to push this object and this object, but what is going to help me to push this object is just the other object. So that's basically Pulley system. Okay, so the weight of 9 kg mass is going to help me to pull 5 kg because I've got a pulley here. Okay, now look at this. Allow me to call this M1 and call this M2. As long as it is connected to one rope, this is one rope from here all the way to there. The pulley system here, the tension here and the tension there is the same. As long as it is connected to the same rope, the tension is the same. Okay? Come on, guys. Now look at this question. A 5 kg object placed on a frictionless, meaning there is no friction at all, horizontal table is connected to a string that passes over a pulley and then is fastened to a hanging 9.00 kg object as shown below. So we have the diagram there. Part 1 is saying draw a free body diagram of both objects. Let's now go ahead and draw free body diagram for each object. How can we do that, guys? Let's start with the one for 5 kg mass. Now, how can we draw a free body diagram for 5 kg mass? Now, this is very simple and straightforward, but it just needs you to understand certain concept. Now, look at this. I want you to understand one thing. 5 kg block is seated on the table. Now what happens when something is sitting on the table? That thing is exerting what? The weight force down here. Then now the same surface is exerting the what? There is a force that is perpendicular. Come on, guys. The force that is acting perpendicular to the surface of the table in this case is what we call the normal force. Now look at this. There is no friction at all, meaning there is no force that is opposing. There is no force that is going in this direction. The other force that is acting is the tension force because of this rope. Now for this object to start moving, now before we even do that, what I want you to understand is 5 kg is less than 9 kg. Therefore, this object is going to go in this direction. Now we know that we have got the tension that is moving in that direction. Now that is another force. Now let's now make this thing to be more sensible. So we have got the object here. Now let me put it here. This is the object. Now this object is 5 kg mass. There is a force, that is the weight force, acting downward. There is a force that is acting upward, that is normal force, and there is a force that is tension force. Now this is the free body diagram for the 5 kg object. As simple as that. Come on, guys. So this is the free body diagram. Now look at this. I'm making a simple mistake. This is not normal force. This is the tension force. So the tension force is the force that is supported by the rope. That is the tension force. That's all. There is nothing more. Tension force is defined as the force that is supported by the rope. You see now. Then weight force is the force that is exerted by the object on the surface. What of normal force? Normal force is the force that acts perpendicular to the surface. In this case, this object is sitting on the table. Now the normal force is acting perpendicular, making 90 degrees to the surface. That is the normal force. There's nothing complicated there about the forces, guys. So yeah, now let us look at the other one. So the other one, what I want you to understand is that the tension force, this object is moving in this direction, meaning we have got the weight force for this guy, and then we also have another force that is acting upward. That is the tension force. That's the only thing that we have. So I'm going to get this and put it here. The 9 kg object, the forces that are acting, we have got the downward force, that is the weight force, and the upward force, that is the tension force. Come on, guys. Now what I want you to understand again is that this is just the free body diagram. So free body diagram, you are showing the forces acting on that object. So if you want, you can dismantle them like the way I've done it, or if you want, you can just do it direct from the diagram here. So you say there is a force that is acting downward, another force that is acting upward, another force that is acting downward, another force that is acting upward. So what I'm going to do is I'm going to put tension force, you put arrows, the weight force, you put arrows, again the weight force of that object, again the normal force as N, then another force going in this direction, that is also the tension force. So these are the forces. This is the free body diagram. Now you do it, you can either get it like this, the way I've done it, or you can write them direct from the diagram. Nothing is complicated. Everything is okay. Now look at this, guys. Now part 2 is asking us to find the acceleration of the two objects and also the tension in the string. That's why the question is not the tensions, because the tension is the same. So look, we are going to do this. Allow me to call this tension 1, allow me to call this tension 2. So then this, we have said let this be equal to M1, let this be equal to M2, meaning that this is weight 2 and this is weight 1. Let's make sense out of it. I'm going to show you 2 ways on how you can find acceleration. The first method that I'm going to show you is the simplest method out of all. We know that this pulley system is going to move in this direction. Look at this, guys. Why is it going to move in this direction? If we tend to calculate the weight force, so what is the weight force for 1? The weight force is mg, or m1 times g. So what is m1? M1 is 9 times 9.8. Let's find the weight force there. What is 9.8 times 9? That is 88.2 kgs. Oh, come on, newtons. So we have the weight, that is W1, being equal to 88.2 newtons. Now look at this. Let's now go ahead and look at weight 2. So weight 2 is M2 times G. What is M2? M2 is 5 times 9.8. So we have 9.8 times 5. That is 49. Definitely, I can clearly see that. I'll put it. Where should I put it? Okay, I'll just put it here. It's 49 newtons. Then this guy is 88.2 newtons. We can clearly see that W1 is greater than W2. Therefore, the system is going to move where there is heavier weight. So, in this case, this object is going to move in this direction. It's going to move in this direction. I want you to understand that when it is moving, when this object, which is 5 kg, is moving in this direction, the acceleration is positive, because in that case, it is moving toward positive x-axis. But now, when it is moving in this direction, it is moving toward negative y-axis. Acceleration is a vector quantity. it is negative a. The acceleration is going to be negative. Now let us look at this. Let's make sense out of it now. We want to find the formula that is going to help us to find the acceleration. So we say the summation of forces, we're talking about the force that makes the whole system to move in this direction, is basically the weight force, the weight of 9 kg, which is weight 1. So I'll say that is the force that is making the whole system to move. But now, according to Newton's second law, I need to replace this with mass times acceleration. So what happens? Mass times acceleration, remember, this object, this weight 2, is not only pushing mass 1, but it is also pushing mass 2. So therefore, I need to add that mass. So it's going to be m1 plus m2 in the brackets times acceleration being equal to the weight force. Now we said it is mg, so that one is m. Now which m1 g, divide both sides by m1 plus m2, even here by m1 plus m2. So we cancel this. Acceleration will be equal to, what is m1? M1 in that case, or let me just put it like this. So this is the formula that I'm supposed to use to find the acceleration. Let's plug in the values. Now that we have got him, so I think I can get rid of this because I no longer need this part of the free body diagram. So A is equal to, what is the M1? Is 9 times 9.8. Although we found it, why can't I just do this? Because I don't want to have, okay, we found it. So A is equal to 9 times 9.8. You divide this by M1 is 9 plus 5. So A will be equal to, yeah, so A will be equal to, we are going to have, what are we going to have? 9 times 9.8 is the same as this answer, the one we found, which is 88.2. You divide it by, that should be 14. Okay? Yeah, it should be 14. So 88.2 times, so we divide it by 14, so we have 88.2 divided by 14. What answer we're going to get? That is 6.3. Acceleration is 6.3 meters per second squared. This is the acceleration that we have. Where should I put it? I'm going to put it here. But what I want you to understand here is this. It's so interesting. I'm going to give you 6.3 meters per second squared. Look at this. Look at this. Another method that can help me to find acceleration. I'm going now to start resolving the forces in both objects. Let's start with object 1. Okay? The one for mass, the one for W1. So here the object is moving in y-axis. We can clearly see here it's going down. So the summation of forces in y direction is equal to, what force do we have? We have got one force which is pointing upward, which is the tension force. I'll call that tension 1. Anyway, just say T, because it's the same thing. So then W1 is going downward, so it will be W1. Now, the summation of forces, now we are only dealing with M1. So we're not going to consider M2. Okay? Therefore, the mass, the summation of forces, it will be replaced by mass times acceleration according to Newton's second laws of motion. So M1A, but because it is going downward, the acceleration is negative. Therefore, I said the acceleration is negative here. So it will be negative M1 times A is equal to T1 minus this. So make T as the subject of the formula. Shift W1 to the other side. So it will be minus this, then plus W1 is equal to T. To make things simple, T will be equal to W1 is the same as M1G, then minus, which is this one, I'll put this one now, minus M1A. I'll call this equation 1. Now, this one, I can use it to find the tension force. That's okay. Just from here, I can plug in the values and find the tension force. Still, the answer is going to be the same. So now, without wasting much of our time, let's go ahead and plug in the values for tension force. But I'm going to show you another. From here, we are finding the tension force. What is? I can factor out M1. I have G minus A. So T will be equal to, what is M1? M1 is 9. Then G is 9.8 minus A 6.3. So let's see. What will be the tension force? So we have 9.8 minus 6.3. The answer I'm getting times 9, that is 31.5. 31.5 Newton. Okay, so 31.5 Newton is my tension force. But since it's not clear, let me write it. 31.5 Newton. That's the tension force. So let me just put it here. Where exact? Okay, I'll put it here because I don't have enough space. Now, after finding this, I want us now, so in short, we are done with this question. But I want to show you another method on how you can find the tension force. At the same time, another method on how you can find the acceleration. So after getting this, another thing that I want us to understand is the summation of, here we are going to have this. It's going to have the summation of forces now in x direction. In x direction, this object is moving in x, because we can't consider y because it's not moving in y direction, which is the one for 5 kgs. It's just moving in this direction. The only force that we have is the tension force. So now, because the acceleration is positive, summation will be replaced by m2 times a is equal to tension force. At the same time, if I use this formula, I will still end up getting this answer. So plug in the values. What is m2? m2 is 5. The acceleration is 6.3 is equal to tension force. So what is 6.3 times 5? You still end up having the same answer. T to be equal to 31.5 newtons. So the tension will still be the same. So you choose which formula do you want to use. Do you want to use the one for M1 or the one for M2? But the answer is going to be the same. You just choose one. After finding this tension force, I want to show you now another method. This tension force and this tension force, they are the same. So I'm going to replace this guy with where I have T there. So that becomes M2A is equal to M1G minus M1A. Now let's make A as a subject of the formula. Let's shift this to go to the other side. That becomes M2A plus M1A is equal to M1G. Now at this point, what I want you to do is, let's make A as a subject of the formula. Let's factor out A. So A, open brackets, if I want I can start with M1 plus M2 is equal to M1G plus, it's just M1G. Then I will divide both sides by M1 plus M2, even here by M1 plus M2. So A is equal to, this is the same formula I had. Now that one was just a shortcut. So you can clearly see that I've also gotten the same formula. If you plug in the values, you still get the same answer. So that's basically under, that's what we're supposed to know under Pulley system, as long as it doesn't have friction at all. But there's another video that I explained when there's friction, when friction is present. Now look at it, just search on YouTube, just search transcended Pulley system. Then it's going to come with friction, it's there. I explained everything. Now let's talk about this interesting question, which is also under, it's under what? Is under Pulley system. Pulley system. So what is Pulley system? Pulley system. So let's get into it. So I have actually solved a lot of questions for past papers and also advanced Pulley system practice questions that can help you to understand more under Newton's laws of motion. Now look at this, guys. This question is a combination of Pulley system and incline. Okay, so let's read the question. Two blocks of mass 3.5 kg and 8 kg are connected by a massless string that passes over a frictionless pulley as shown below. The incline are frictionless. Find the tension in the string. Okay, so how can we find the tension in the string? How can we find the tension in the string? Okay, now let us look at this. One thing I want you to understand is that whenever we're talking about if there is an incline here, I'll just start with a simple concept. Here is the incline. Then there's an angle here. You have got an object which is here. This object, no one is pushing it, but one thing I want you to understand that whenever we're talking about incline, there is the force of gravity that will always push an object to go down. And this Fg is given by mg sine theta. There is a video that I explained where this mg sine theta is coming from. Okay? Then the normal force is given by mg cos theta. There is also a video that I explained about these two things. Just go on search button on YouTube and search incline transcended. That video is going to come and you're going to understand where this mg sine theta and where this mg cos theta is. But no one is going to ask you where they are coming from. As long as you know that Fg, any incline, Fg is always mg sine theta. Normal force, I'm not going to say normal force is always mg cos theta, but in some certain circumstances it can change. But in this case, it's just mg cos theta. Okay? That is under incline. That is what I want to know for now. Then, another thing that I want you to understand, if there is no friction at all, this object is going to be pushed by Fg only, meaning that the summation of forces is equal to the Fg. So how can I find the acceleration? According to Newton's second laws of motion, we replace this with mass times acceleration. So it will be ma is equal to mg, because Fg is mg sine theta. So I can cancel mass, and I'll have a being equal to g sine theta. So I can find acceleration using this when it comes for this guy. Okay? Now let us assume to say you are pushing. Now this object is coming down. Now let's now take an instance where this object is going up. Okay? Now this object is going up the incline. There is a force that is pushing this object going this side, which is going to be F. Remember, as long as there is an incline, Fg will always be there. Get me right there. Fg will always be there. So Fg will try to bring an object down. So you say the summation of forces, the force that we have, the force that is pushing the object going upward is the applied force. Then Fg is opposing. Fg will always be going down. So Fg will be acting downward here. So therefore this summation you replace with m times m. Then F you are going to be given. Then Fg is mg sine theta. So you divide both sides by m, here by m. In that case, acceleration will be equal to, it's going to be found by this. Now that we have got this idea, let's now talk about the pulley system. So pulley system, in a case where we have got we have this. We have a pulley system. There is no friction at all. How do we find the acceleration? There's another mass here. If we call this m1, we call this m2. How do we find the acceleration? This is the tension force. What happens here is simple and straightforward. The summation of forces, this object will always go down. The force that makes the whole system to go down is the weight of W1. So W1. So that becomes W1. So this, now we need to add the mass. This guy is not going to be pushing only M1, but it's going to be pushing also M2. There is no friction at all. So then it is going to be M1 times M2 or plus M2 times acceleration outside is equal to, this is M1G. You divide both sides. This is the same as the question we are from solving for Pulley system. These will cancel. A will be equal to M1G divided by M1 plus M2. Now we are building up from these two guys. Another case of Pulley system is a situation where you have a Pulley system. Now it is both objects are hanging. Okay, so you have this. Let's say this is M1 and this is M2. What I want you to understand is that this is the tension force. We can say T1, but the tension force is going to be the same, T1, T2, but at the end of the day the tension is the same. So we are assuming that the object now is moving in this direction. Depending on the object that has got bigger mass, that's where the system is going to be moving. So now we are assuming that M1 has got bigger mass than M2. So the weight of M1 is greater than the weight of M2. Therefore, the object will move in this direction. Now, let us look at this. When the object is moving in this direction, this part, the mass, we are going to say the summation of forces is going to be equal to the force that is making the system to move in this direction is the weight force of this guy, but this guy has to overcome the weight force of that guy because we have got two. They are both hanging. It's different from the previous case. So it's going to be W1 minus W2. Then here we are going to have M1 plus M2 like we had the previous example. Then it's going to be M1G minus M2G. Then you divide both sides by mass. It will give you this. So here I'm explaining everything about the Pulley system. Now we want to get the concept of Pulley system and the inclined plane, then we add. Now this concept that I've given you and the concept of the incline that I've given you here. Now let's merge them together. We see what we're going to have. That is the question that we have here. So it's a combination of the Pulley system and the inclined plane. Look at this. We need to identify the object that has got heavier mass. In this case, this is the guy which has got heavier mass. Now let's call this as M1. So I'm going to say, how do we answer this? Just say let 8 kg be equal to M1 and let 3.5 kg be equal to M2. Look at this. This one has got bigger mass than this. Definitely, the weight of that guy is going to go where? The system is going to move in this direction. That's what I want you to understand. So, the question is, the two blocks of mass 3.5 kg and 8 kg are connected by a massless string that passes over a frictionless pulley, as shown below. The incline are frictionless. Find the tension in the string. How do we find the tension? Okay, we need first to find the acceleration. Okay, but what I want you to understand is that if you want to find the tension force, we have got the tension force of this guy and tension force for this guy. Both tension can give me the same answer. I can choose. Now in this case I'm going to do both, but for you guys you're supposed to choose one. But I want to show you that both 8 kg and 3 kg can give me the same answer. That's what I want to show you. Now let's drive the formula that is going to give us the tension for the first one. Now this object, if we look at this, we are saying that this is now M1 and this is M2. This is M1. What I want you to understand is this. Since this object is moving in this direction, get me right there. Since that object is moving in that direction, then we have got the tension moving in that direction. So we'll say the summation. Now the forces that we have, there is a force of gravity Fg, like I said, under incline, that is going to be pulling this guy to go down. That one is going to act as the friction force at that point. So there is Fg which will go in that direction. Again, there is Fg which is pulling this guy to go in that direction. That's the basic idea. So the summation of forces, if I look at it, I start with this one. The force that I have, there is Fg, okay? There is Fg. So let's call this Fg1, this one Fg2. So Fg1 should overcome the tension force. Then this is going to be M1A is equal to Fg is M1G sine theta. Now the theta, I'm not going to say theta 1 because they are both 35. But if they are different, you have to specify it to say theta 1 is for this one, theta 2 is for that one. But in this case, nothing is going to change minus the tension force. Our goal is to find the tension force. Shift T to the other side. T will be equal to M1G sine theta minus M1A. If I use this formula right now and plug in the values, I'll be able to get tension force, but I don't have the acceleration. Okay? Now, if I want for this one, there are two ways here. This guy here is going to give me the summation of forces. The tension force is the one that is going to the other side, pushing this guy here, minus the Fg2. So this becomes M2A is equal to T minus M2G sine theta. Shift mg sine theta to the other side, that becomes M2A plus M2G sine theta is equal to T. Again, if I use this formula, I'll be able to get the same answer as that. The best way is just find the acceleration, because here if I want, I can make acceleration here as a subject of the formula or here as a subject of the formula. Then what I can do, I can start now plugging the value. But the best way is just find the acceleration, the value for acceleration direct. But how can we find the acceleration? I'll use this. The summation of forces, the force that makes the whole system to move in this direction is Fg1, but Fg1 has to overcome Fg2 because it's also moving in the other, it is pointing to the other direction. So it will be minus Fg1. Then this now it will be M1, like the way we did M2. Now this guys is M1G sine theta minus, now I don't have enough space, so I'm going to push this side. I want to push this part this side so that I have enough space. So again, I have got M, so this is G2. So M2G sine theta. Now at this point, theta is the same, sine, then M1 is the same. Now here we need to multiply by A, acceleration, don't forget that. But now I can get rid of this to create more space. Remember, I'll come back and plug in the value so that I prove to you that indeed I can have what is possible. I can have, I'm going to find the same answer. I'll divide both sides by M1 times M1 plus M2. So I'll have A being equal to, I'll factor out M1, oh sorry, not M1. I'll factor out G sine theta, then open brackets, I'll have M1 minus M2. Then I divide this by M1 plus M2, like that. Now let's go ahead and find the acceleration. So we'll have acceleration will be equal to, what is my G? 9.8 sine 35, open brackets, M1 is 8 minus 3.5. Then I divide this by 8, which is M1, plus M2 is 3.5. So what I'm going to have, I'll get rid of this and put acceleration here. So I'll first start with 8 minus 3.5, that is 4.5. So 4.5 times, so we have got now 9 sine 9.8, then sine 35. The answer I'm going to get times 4.5, that is 25. So we have acceleration being equal to 25.5 I'll just say 0.3. To get the accurate answer, I need to get at least 3 decimal places, 9.5, like this. I divide this by, that should be 11.5, right? Yeah, so I'll say 11.5. So then acceleration will be equal to, so we have 25.295. I divide this by 11.5, so that gives me 2.19956 meters per second squared. So the best way, I'll say 2.20 meters per second squared. Why am I going to put in 2 decimal places? Because this, you look at the question, is in 2 decimal places, so that is the answer. So this is the acceleration, but the question is we need to find the tension. They're not asking about acceleration. Okay, so find the tension in the string. Now you choose either to use this or that, but the answer will still be the same. So let's plug in the values here. I'll start with this one. So you choose any. So without wasting much of time, just find the acceleration and find this formula, then plug in the value. So t is equal to, what is m? At this point it's possible I can factor out m, but it's fine. Let's just do direct. So m is m1 is 8, right? Yeah, we have got 8. So it's 8 times g is 9.8, then sine 35 minus again 8 times acceleration 2.2. So what will be the tension force? So let's first do 9.8 then times 8, that is 78.4. So this 78.4 times, you say sine 35, that is 44.9683926. so this one just do direct minus, then open the brackets, then you say now 8 times 2.20, then you close the brackets. So I'm getting my tension to be 27.368. So if I round it off, it's 37 newtons. So this is the tension force. So in short, I'm done with this question, but I want to prove to say, you guys, it's actually possible. You can also use this other one and find the same answer. So we know that acceleration is 2.20 meters per second squared. Let's use this other one. So I'm using this one now to find the tension force. So T is equal to, what is M1 or M2, sorry, that is 3.5 times 2.2, I put them in brackets, plus then again 3.5 times 9.8, then sine 35. So T will be equal to, now we have 3.5 times 2.2, that is 7.7. So we have 7.7 plus, again we have 3.5 times 9.8, that is 34.3. Now this times sine 35, that gives me 19.67 67367, like that. Let's now add those two. So that plus 7.7, that gives me exactly 27.37 newtons. So as you can see, both are giving me the same answer, so it's just a matter of you guys knowing which one to use. So that's basically Pulley system when you have got the combination. Now remember, Pulley system is one of the most important thing under Newton's laws of motion. Know that concept when there is friction and there is no friction. I have explained everything on our website. There are some detailed videos that can help you to understand fully under Pulley system. Okay, so I hope you are enjoying this video, but you can actually access our full topic videos on our website. Just go on Google and type Transcended Institute and you'll be able to find our website. Now here is our website. You can clearly see here that we have got all the topics. You can actually access all the topics. So we have math, physics, biology, as well as chemistry. So you can access any of these. If you want maybe physics, you want to access more videos on Newton's laws of motion, there is a topic. All the topics are there: dimension analysis, vectors, linear motion, Newton's laws of motion. I'll click here. There are 16 lessons. Now here I have explained everything in details. There is Newton's first laws of motion, second, third, contact forces, elevators, tension forces, other things that I've not explained in this video. Okay, you'll be able to find them. There is pulley system and incline without friction, and pulley system with and incline with friction. So that can help you to understand more. Incline plane, best explanation, detailed. We have got quiz questions, then Newton's laws of motion practice questions. So this video has got a number of questions, any type of questions under Newton's laws of motion. I solved everything. Go on website. There's also other questions. If you click on tutorial sheet 1, you'll be able to find other questions on Newton's laws of motion. The best way to do is just register with us right now. Don't waste your time. Register using the link in the description below. If you're not be able to see the link in the description, go on Google yourself, just type Transcended Institute. You'll be able to find the link. Okay, you can pay for yourself, get access to any of the course that you want. Imagine you pay for a month and then you'll be able to access the practice questions, the full topic videos, as well as the tutorial sheet. So these are the things that we have, and these things can help you to prepare for your exams, tests, quizzes, anything, as long as you are doing physics under natural sciences. Not only physics, but we have all the courses for natural sciences: mathematics, chemistry, biology, and as well as physics. Okay, so let's go back and continue our video. Okay, now let's jump into incline plane. Okay, let's jump into incline plane. So incline plane, just imagine you are moving at a slope. So that one we are going to consider it as an incline plane. Okay, so we want to show, the question is that a block of mass m is placed on an incline that makes an angle of theta with a horizontal. The block experiences kinetic friction as it slides downward. Show that the coefficient of kinetic friction, which is mu, is given by this formula: mu k is equal to tan theta minus acceleration divided by g cos theta. So how can we find that? Let's first come up with a free body diagram. A free body diagram of incline looks like this. We have got an angle that is theta. Then we have this. That's an object. Now this object is moving under the influence of gravity. It's sliding down, meaning it's going. The only force that makes the whole system to go down, it is Fg. Fg is naturally present, but again there is friction force that is opposing the motion. Okay, but remember, what I want you to understand is that when you're talking about inclined plane, Fg is always given by the mg cos sine theta, and then the normal force is given by mg cos theta. These are the things that I want you to know. I explained in the video, the one for inclined plane. You can just search on the search button. I explained everything, where these formulas are coming from. Okay, I explained everything where they are coming from. So now what I want you to understand is this. So another force that is acting in this case is the force that acts perpendicular to the surface, that is the normal force. I want to show you again where it's coming from. It's like you are interested, you want to know where it's coming from, right? Then the force that goes downward is what we call the weight force. Now look at this. The weight force is the force that is acting by the what? By the object. Okay, so now to balance the normal force, we are going to have this. It will go like that. So the angle that is being formed here is the same as the angle which is going to be formed there. So using SOHCAHTOA, this is the weight force, which is actually mg. To balance this, what I want you to understand that this is opposite, meaning this is mg sine theta. So this is going in the same line as fg. Therefore, fg is equal to fg sine theta. At the same time, the normal force is in the straight line with this one is adjacent, so this one is mg cos theta. So the normal force is going in the straight line with mg cos theta. Therefore, the normal force is mg cos theta. Now, after looking at this, now we can now start working around with the forces. The summation of forces that in x, we're going to assume that that is the x direction. The force that is making the system to go down, that is Fg. Now there is also friction force which is going to carry negative. The summation of forces, according to Newton's second law, it is replaced by mass times acceleration is equal to this one. Fg is mg sine theta. Friction force is mu k times the normal force. So the normal force, again, we're going to replace ma is equal to mg sine theta minus, so now this is mu k, normal force is mg cos theta. At this point, I can go ahead and cancel mass, and I'll have acceleration, the formula for acceleration being equal to g sine theta minus the mu k, then g cos theta. So this is the formula that I want you to know. In this case, if the question, they give you the digits, then they'll ask you to find the acceleration. But here we want to make mu as a subject of the formula. So what are we going to do? We are going to shift this to go to the left side and a to go to the right side. So then we are going to have mu k g cos theta being equal to g sine theta minus a. Let's divide both sides by g cos theta, even here g cos theta. I need more space. We just want to show that that formula is given by that. These two can cancel. Then now I have mu k being equal to g sine theta minus a. I divide this by g cos theta. Let us look at this. If I have x minus 2 minus y minus 2, or if I've got x divided by 2 minus y divided by 2, it's the same as x minus y, then I divide it by 2. It's the same thing. So now I can take this back to that. There is no problem. At the same time, what I want you to understand is this. If I have maybe 4, okay, 4 minus 3, I divide this by 2. This is the same as 4 over 2 minus 3 over 2. It's the same thing, because I can take it back to say that the common denominator is 2, and it will still get me back to that. So this is the same concept that I'm going to use here, meaning that this mu k, is given by g sine theta divided by g cos theta, then minus a divided by g cos theta. Now let's go back to trig. You guys, you understand trig to say tan theta, or before we even do that, I want you to understand that we have got mu k, g and g can go, and I have got sine theta divided by cos theta minus a divided by g cos theta. So you understand that tan theta is equal to sine theta divided by cos theta. So I'm going to replace where there is sine theta divided by cos theta with tan theta. So mu k is equal to tan theta minus a over g cos theta. This is as exactly as this, hence shown. So that's the basic idea behind incline when it comes for such type of question. Okay, let's talk about um, friction force. So we're going to focus more on kinetic friction and static friction. So what is static friction? So static friction is the type of friction that is present when an object is at rest, it's not moving. Then kinetic friction is the friction that is present when an object is in motion. It's making sense, right? Yeah, so let's say we have got an object that is moving in this direction, or let's say first we have this object that is just at rest. Now what happens? So if we have got a force of 50 newtons that is pushing an object, and there is an opposing force of 50 newtons, this object is going to be at rest, so it's not going to be moving. At this point, this friction force is static. Static meaning something is not moving. So the applied force is equal to the friction force, the static friction force. Now, the moment this applied force is greater than this friction force, now the object is going to be moving, and we expect to have the kinetic friction. The kinetic friction, which is going to be Fk. Now, how do we tend to find the same kinetic friction and static friction? Look at this. So I have got an interesting question which is saying a 25 kg block is initially at rest on a friction on a horizontal surface. A horizontal force of 75 newton is required to set the block in motion, meaning that was the force that was required to make the object to be moving. So meaning that was the force which was present when the object was not moving initially. Come on, guys. After it is in motion, now it is in motion, meaning now we have changed from static friction to kinetic friction. A horizontal force of 60 newton is required to keep the block moving with a constant speed when the object is moving with a constant speed. Constant speed has got acceleration of 0, meaning that the net force is 0. Look at this. Find the coefficient of static and kinetic friction from this information. Let's now come up with a free body diagram. The data that we have been given, the first one is we have got an object, the force that is applied. Initially, this force is 75 newton. Now, as it is moving, it has got a force of 60 newtons. But we have the friction. So I'm not going to say we have got static, but we're going to start with the first one. So the question is we need to find the coefficient of static friction. Static friction meaning an object is not moving. Therefore, the summation of the forces that we have the applied force minus the same static friction. So since it's not moving, the net force is 0. The applied force is 75 minus the static friction is given by mu s times the normal force. Now, another force that is applying here, we have got the weight force, which is mg, and the normal force acting perpendicular to the surface. So the normal force in this case is equal to mg. As simple as that. So then we are going to say we are going to shift this to go to the other side, to the left side. So we have the mu s times the normal force is equal to 75. So normal force, replace normal force with mg being equal to 75. So we divide both sides by mg, even here by mg. So the mu s will be equal to 75. You divide it by m is what is the m? 25 times 9.8. So therefore our mu s becomes, so we have 75. The mu s is always less than 1. So the coefficient of the coefficient of friction is always less than 1. But there are some situations where you can find it to be greater than 1. But in that case, there is an explanation that we have to. There is a conclusion that we have to make. But at your level, it's less than 1. Okay. So 25 times 9.8, that is 24 point. How possible is it? It's not possible. So it's 245, not 24. So it's 245. So what happens there, I want you to understand this. The normal force is always greater than the friction force. Okay, that's the basic behind, because this is going to be on the denominator to find the mu. So then the mu s in this case is going to be 75 divided by 245. That becomes 0.3. Okay, so 0.301, which is the same as 0.31. This is the mu s, that is the coefficient of static friction. Now let's go ahead and look at the, now the object is moving, meaning when the object is moving we have kinetic friction. So when kinetic friction is present, we are going to use the force that was there when the object was moving. So here we are saying that after it is in motion, a horizontal force of this, that's what we have. Summation of forces, still the applied minus the Fk now. So now at a constant acceleration, the net force is 0. We still replace this with 0. It's different from that one, it was not moving, that's why it was. Now here it is at a constant speed. So the applied minus this is going to be the mu k times the normal force. So 0, the applied mu k, then this is mg. Shift this to go to the other side, mu k times the normal force, which is mg, is equal to F divided by mg divided by mg. This will go, and mu k will be equal to the F divided by mg. Let's go ahead and plug in the values. What are we going to have? So there we go, guys. Mu k is equal to the friction force is, or the force, the applied force is 60 divided by the mg is, the m is 25 times 9.8. So the mu k is 60 divided by 245. Now what are we going to have? Let's see what we're going to have. Now we have the mu k being equal to, so we have 60 divided by 245, and I'm getting 0.2449. Should I round it off? No, I will just say it's 0.24. If you want, you can say 0.245. Mu has got no, it has got no units. Why? Because you always have the force, the Newton on top, down Newton, so they tend to cancel. That's the basic idea. Remember, I have explained more concept under, I've got more videos under Newton's under this subtopic for friction. Just go on website, you'll be able to find the video. If you go on website, you'll be able to find the videos of this. Okay, so I think if you have gone to our website before, I just want to show you something. If you have gone to our website before, you are going to be able to see this. So go on physics, you'll be able to find very interesting questions there. Under Newton's laws of motion, I've got all the topics under Newton's laws of motion, plus the practice questions, the past papers, that can help you to go far in your academic journey. So as you are watching this video, I hope you'll be able to explore our website and at least check the videos that we have. Yeah, so that's what I wanted you to know under friction force.